Next is indirect loading test. In case of indirect loading test, there are three methods: synchronous impedance method, or it is called as a EMF method. Second, ampere turn method or MMF method, and third one is a Portier triangle method or ZPF method. So we'll see the first one, synchronous impedance method. But to calculate the voltage regulation by using this method, we require some parameters to be known, which are nothing but the RA and short circuit test and open circuit test. So let us see how to perform the short circuit test, open circuit test, and the third one is how to measure the RA. So first point, data required for indirect method. First one is RA. Okay, and to measure this armature resistance, we require armature resistance test. What we have to do? Suppose, so I will connect one ammeter over here and I will apply some DC voltage across these two terminals. Any doubt? Remaining this field is kept open, and let us suppose VDC is applied and current IDC is measured through these two winding. What will happen? How to calculate resistance if I know IDC and VDC? VDC upon
IDC.
IDC. Okay, good. So in this way, let us suppose first resistance is RY, because we are going to measure in between R and Y. And this one is B. So it will be VDC1 upon, sorry, IDC1. Then again, I have applied through in between two terminal like Y and B. So that resistance will be RYB. It will be VDC2, that will be the second reading, and IDC2. And the third one is R. Which one is remaining? BR. It is nothing but VDC3 upon IDC3. And once I got these three value, RDC, it will be RRY plus RYB plus RBR upon 6. Okay, so I will get the DC resistance, but whenever there is a skin effect. Okay, so in case of AC, due to frequency, that skin effect exists. So because of that skin effect, the AC resistance, it is always greater than the RDC. Okay, DC resistance. So what is the relation between that RDC and RAC? So RA is nothing but the AC resistance. It is 1.25 to 1.5 times this is RDC. Okay, so by using this formula, that I will get the armature resistance. I got the value of RA. Then second thing, we have to measure open circuit test, and it is connected to the prime mode, and we are going to measure VOC. We are not connected any load over here. VPH. See, we can measure this VOC line voltage, and we know the relation between VOC and VPH, or we may measure this VPH also. Generally, we require VPH. Okay, so let us say suppose this is VOC. Fine. And here I required one ammeter. As DC supply is given to the field winding, I will connect one DC ammeter over here. This is variable terminal. First step, field excitation is kept at 0. Okay, then we have kept this open circuit. We have not connected any load over here. Then we'll start the prime mover. As it is an induction motor, by using auto transformer starter, we can start the induction motor. Once it started, we have to set the rated speed. Okay, rated speed. So once prime mover is started, this alternative or field winding is started rotating, gradually we have to increase the field excitation. Which reading we have to take for open circuit test? VOC. But I want phase voltage, so I will measure this one. Okay, I will connect 1 voltmeter and I will measure this one. But with respect to what? How to vary this VOC? By varying the field current. So I'm going to measure this IF. So in observation table of open circuit test, we have to measure IF and VOC. So gradually I will just maintain it as a 0. Let us suppose 1, 0.2, 0.3, 0.4, 0.5. Gradually I will get some values of VOC. Which value we have to consider? See, as it is an open circuit voltage, we may increase this VOC up to 25 to 50% of the rated voltage. Let us say suppose phase voltage is 230. This VPH rated phase voltage is 230. So we may increase 50% more. In case of open circuit, we may increase the field current till this VOC is 287. So in case of open circuit test, I can increase the field current to get 25 to 50% of the rated voltage.
Yes, sir.
If I'm going to plot the curve like let us say suppose there is a IF and there is a VOC, that is a VOC or EPH. Generally, we are denoting it as a EPH. EPH is nothing but the open circuit voltage. So if I'm going to plot this characteristic, I will get the curve like this. And this curve is called as a magnetizing curve, where this EPH, it is equal to EL upon root 3. So generally, we are measuring this VOC or EPH, that is a line value, and the phase value can be calculated as EPH is equal to EL upon root 3. Just plot this phase value with respect to IF and I will get the curve like this. So let us say suppose this is IF1 at which I am getting rated voltage, V rated, and let us say suppose this is IF2 at which I will get E0. That E0 is nothing but second is a short circuit test. In case of short circuit test, these terminals are shorted by using ammeter. I'm going to connect these all three terminal through ammeter. Means it is shorted by using ammeter. Any doubt? R, Y, B, and it is coupled with prime mode. Again, there is a field excitation. So in this case, strictly we have to keep this field resistance at higher value to maintain the field excitation initially 0. For which value we have to increase the field excitation? Up to which value? Okay, so the observation table will be, yes, here it will be IF. Then here ISC. ISC is nothing but the short circuit current. We have to increase up to which value? I will get the rated
current.
rated field current. Once I got the values of ISC versus IF, I will plot this characteristic. This is field current and this is ISC, short circuit current. So this will be the gradual or linear relation. So I will get one straight line. This is IFSC at which I will get rated short circuit current, that is IASC. In this particular lecture, we have seen what is direct loading test. Okay, after that, in case of indirect loading test, the data which is necessary to calculate the different regulation methods. So which are nothing but first is the armature to measure the armature resistance. Second is to perform the short circuit test, and third one is to perform the open circuit test.